Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
All right, good to see you, sir.
Great to be with you, Joe.
It's a perfect time to bring you on because things are getting very wild.
Yeah, there is a lot of misinformation. You know, some people said, I invented 3i Atlas, this object, in order to distract attention from the Epstein files.
Is that what people are saying?
Yeah, and I said, look, this object is the size of Manhattan Island. It's at 4.5 times the Earth-Sun separation. If I was able to put it out there, you know, I would be more powerful than the Pope. And because we're talking about a giant object that you can see from any place on Earth. You know, you can buy online a telescope that will allow you, 0.5 meter in size, that will allow you to see it. It's out there. It cannot be faked.
Well, those people are fools. You can't listen to those people.
I don't listen to those. I don't listen to many people, you know.
Initially, a lot of people were dismissing your concerns, and they were saying that this object is nothing but a comet, and it's very normal. But then as it got closer and as we got more data, it seems like you're correct.
Well,
this is a very unusual object.
There is something really important to recognize here, that usually when you deal with scientific matters, they have very little impact on the future of humanity. Very little. You know, if the neutrino has a little bit of a mass, it doesn't really matter. You know, when we discovered the Higgs boson, the biggest impact was to confirm some idea we had back in the 60s. And, you know, obviously that affected, you know, those people who got the Nobel Prize. But most of us continued as if nothing happened. However, here, if we ever encounter alien technology, everything will change. It will affect the financial markets. It will affect politics in a major way. So my point is simple. This is different than other scientific matters. And the intelligence agencies know very well that events with very small probability have to be considered seriously because they could have major implications. Just think about October 7th. The Israeli intelligence agencies had a theory that the Hamas will do nothing. And they got data that indicated something is going on out there, but they dismissed it because of their theory. Now, as a result of their mistake, which was clearly a blunder, a lot of people died on both sides. For that, this could have been avoided if they were to consider a black swan event, an event that you put a small probability for it happening, but you look at anomalies in the data and say, look, the implications are so huge, we have to consider it. And, you know, this idea was already considered by the philosopher-mathematician Blaise Pascal. He talked about God, and he said, look, of course, you might think that God doesn't exist, the probability for that is small, but the implications, if God exists, the implications are so huge that we have to discuss it. That was the argument, Pascal's wager. And the intelligence agencies know that. Believe me, the Israeli intelligence agencies will not make that mistake again. Now, here comes an object from outside the solar system, and it shows anomalies. The scientists would say we should be as careful as possible at talking about anything other than a rock. Now, they say that when they know that humanity launched a lot of space junk, you know, a lot of technological objects to space. And we also know that there are 100 billion stars like the sun in the Milky Way galaxy alone. Most of them formed billions of years before the sun. And there are billions of Earth-Sun analogs. Now, we all believe that we came out of a soup of chemicals. You know, that's the scientific narrative of how human intelligence came on this earth. And so it's quite likely that, you know, we are not the first one. Sorry to break the news, Elon Musk was probably not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. And therefore, we should consider the possibility that things like us existed long before us. And you can ask the question, how long does it take our own technology, the Voyager spacecraft that we launched out of the solar system, how long does it take it to move to the opposite side of the Milky Way galaxy? You know, thousands of light years away, it takes less than 1 billion years. And that means that all these civilizations that had their history initiated billions of years before ours could have done it. And all we need to do as responsible scientists is to check if among all the rocks that come from outside of our backyard are really rocks, or maybe one of these objects might be a tennis ball that was thrown by a neighbor. And the reason I say that is, we live at our home, on Earth, next to the sun. We look around us in the cosmic street, and we see a lot of houses just like ours. There are billions of them, probably. Now, my colleagues, those scientists who think traditionally, they say, well, microbes came to Earth very early, therefore they must be everywhere. So let's define our highest priority, searching for microbes on other houses in our cosmic street. And I say, good, you can do that from the vantage point of your home. You can look through the window and search for microbes in your neighbors' yards, but you would need to put $10 billion to develop a big enough instrument that would be able to detect the chemical fingerprints of microbes, on exoplanets. And think about the possibility that there is a resident in one of those houses. That resident might show up in your front door at some point, or you might see an object that arrives to your backyard or your mailbox from that resident.
A black swan event.
A black swan event. Or you might see some construction project from a distance. That might be easier to detect than microbes. So we should hedge our bets. We should invest billions of dollars on both fronts. At the moment, the scientific community is willing to allocate more than $10 billion to searching for microbes, but no recommendation is made to allocate any federal funding to the search for intelligence. And I say that is an oversight.
Now, they have found evidence of microbes on Mars, correct?
Well, it's not conclusive.
Evidence?
We need to bring materials back. It's called sample return, and NASA has plans. We need to bring a sample back to Earth so that in our laboratories we can do isotope analysis and make sure that whatever signatures we see on the rocks there that do look as if they were made by microbes, because we know that Mars had an atmosphere like the Earth. By the way, Mars may have had life before the Earth because it's a smaller body, so it has a bigger surface area for its mass. The mass of the object tells you how much heat it can retain from the formation process, and then the surface area tells you how fast it can cool. And Mars could have cooled faster than the Earth. So life may have started on Mars, actually, because it had rivers, lakes, oceans of water, and it could have been actually delivered to Earth. We might be all Martians. And when Elon Musk, considers going to Mars, it might be the second trip around. We might be going back to our childhood home because there were tiny astronauts inside rocks that were chipped off the surface of Mars that arrived to Earth and seeded the Earth with life as we know it.
Panspermia.
Yeah. And in fact, we can find out if we get this material back to Earth, as NASA is planning to do, hopefully within a decade, then we can make sure that these were microbes. And perhaps we can infer whether the building blocks of these microbes are similar to the ones we have here on Earth, whether the DNA, RNA kind of process took place in both places.
Have you ever done any research on the structural anomalies that are on Mars, particularly the right angles that appear to be a square, this enormous structure?
Yeah, I've seen the data. It's not conclusive, but it's intriguing because both Mars and the Moon have no atmosphere right now. So what happens on Earth is that when an object roughly the size of a person, or smaller, goes through the atmosphere, it burns up, creates a fireball, just like an atomic explosion, and actually you have an object of order a meter colliding with Earth every year. Every year there is an atomic explosion size fireball in our atmosphere. It's not reported in the news because it happens pretty high at an altitude of 50 kilometers, so it doesn't do anything. And 71% of the Earth is covered by oceans. But yes, so these meteors, and they are quite important. Obviously, we know that the dinosaurs 66 million years ago were extinguished by a giant impact by an asteroid the size of Manhattan Island. And we are aware, by the way, that such an impact could endanger us. And that's why the US Congress tasked NASA to find all objects that come close to Earth with a size bigger than a football field, about 140 meters, so that we avoid the fate of the dinosaurs. So we think we are smart, we can see these rocks coming. But just imagine alien technology. It will not follow a path that you expect if it has some intelligence in it. And that's a risk that was never attended to. And I wrote a white paper to the United Nations and to the International Astronomical Union to develop a strategy for monitoring interstellar objects that come from outside the solar system, like 3I Atlas, that show anomalies that could potentially be technological in origin.
The structures on Mars, like what do you think when you look at them? When you see that one that looks like a square?
I think it's very intriguing. Both Mars and the Moon have no atmosphere, so the objects that come into them do not burn up, as I mentioned before about Earth, and therefore they serve as museums. Okay, so any space junk that might have landed on Mars over the past 2 billion years would not have burned in the atmosphere. It would have landed, and we need to check the surface, even if we know that there wasn't any civilization out there over the past 2 billion years because conditions are really harsh.
Right.
Mars may have collected technological debris from other civilizations because it would stay on the surface. It's just like a museum.
But this is an enormous structure. It's at least, they think 300 meters, but
but that's not enormous because
quite a bit longer.
3I Atlas, the size of 3I Atlas is at least 5 kilometers in diameter. And I derived it in a paper a couple of weeks ago because we know that it's losing mass. So, it's mostly from the side that is facing the sun. And you would have gotten some recoil as a result of that in the opposite direction, just like a rocket. And I used, together with two colleagues, 4,000 data points from 227 observatories around the Earth of 3I Atlas that monitored its motion across the sky. And we were able to say that the trajectory is sculpted only by gravity. There is no evidence for this recoil. And that means that the object is very massive. And I derived a value of 33 billion tons. A huge thing, which if you take solid density, it means it's more than 5 kilometers in diameter. So when you mention a few 100 meters, that's nothing.
Right.
And this object, by the way, was discovered just over the past decade of observing the sky. So who knows how much debris collected on the surface of Mars or the Moon, because there are good museums, and by the way, I see that as their most important value. Let me just say one thing about my fundamental point of view.
Okay.
Each of us would live for about 100 years if we are lucky, right? That's the kind of... It's pretty depressing, right? Because there is so much we would like to know, and we have only 100 years, so... And, that already tells you that you need to be modest and humble because you don't have a lot of time, right? So why engage in conflicts? Why reduce the lifespan of other people, in wars? It makes no sense, all of this.
Right.
You have limited time. Let's just use it for something constructive. Anyway, we are born on this rock, which is just 3 millionths of the mass of the sun. It's leftover material from the formation process of the sun. Some debris was left over in a disk and the Earth was made out of that. That's it. And it's just a speck of material, nothing significant. And this Earth was moving around the sun 4.54 billion times before the Vatican even existed. And why do I say the Vatican? Because the Vatican put Galilei in house arrest when he said, I don't think everything moves around the Earth. I see some moons through my telescope. I see some moons. around Jupiter, they don't seem to revolve around the Earth. They revolve around Jupiter. Therefore, the Earth is not at the center. So they put him in house arrest. Today, they would have, canceled him on social media. and my point is, that's the first sign that, humans they want to think that it's all about them,
Right.
And it's not surprising. But the Vatican admitted their mistake. In 1992, they issued an official letter saying Galileo was right. That was 350 years after he died. And, it's the worst public relations affair that you can have, to admit that you were wrong for 350 years. And how could they have avoided that? Very simply, if they said, we have more money than Galileo, we will build an even bigger telescope to figure out the truth, and we would prove him wrong. And then they would have found that he was right. And so then they would have corrected course shortly
or
after.
They would have put more people under house arrest. That's probably what they would have done.
Yeah, so my point is, it's really important in cases like this or 3i Atlas, it's really important to get as much data as possible. Because once you reach a certain threshold, you can't shove anomalies under the carpet of traditional thinking, the way that my colleagues do. Just to give you an example, the first interstellar object was Oumuamua, okay? And it was discovered 2017, and it was really strange because it was shaped like a pancake based on all the data we have, and it was pushed away from the sun by some mysterious force without showing any evaporation, no gas or dust around it. What did these conservative comet experts say? Most recently, just in December 2024, there was a paper of them saying, it's a comet. It's a dark comet. In other words, a comet where you can't see the cometary tail around it. So it's just like experts, specializing in zebras. And they go to the zoo and they see an elephant. So then they say, oh, the elephant is a zebra without stripes. And I say, no, it's a completely different animal. A spacecraft would appear differently than a rock, than a comet, because it will not have a cometary tail. It could be propelled by something else. So let me go back to the big picture that I mentioned before. So we live on this Earth, moving around the sun, and my colleagues in academia, one thing I often say is common sense is not common in academia. Because my colleagues in academia know very well about the story of Galileo. They know very well about the possibility of black swans. And they say, it's an extraordinary claim to imagine something like us, as smart as we are, near another star. And I say, no, it's an ordinary claim. Why would you think it's extraordinary? And by the way, if you decide not to collect evidence, not to look for it, then you will not find it. So I say, extraordinary evidence requires extraordinary funding. You really need to put resources to find the evidence. By not attending to this possibility, you will by not imagining this. And by the way, I much prefer to listen to imaginative science fiction writers, first class, because they're much more interesting than second class scientists who don't have an imagination. And they not only have a problem with discussing alien intelligence, they also have a problem with whoever discusses it, and they would try to suppress that voice. And I think it makes no sense whatsoever, because the public really cares about it. My essays on medium.com, they get a few million readers a month now. The public cares about it. The public funds science. Therefore, scientists should attend to this question, are we alone? It's the most romantic question in science. It's like, so just to finish my big picture before we get to more. So then, we live on this planet. Everyone says, okay, we are not at the center of the universe, but we might be the only intelligent species out there.
This episode is brought to you by Happy Dad Hard Seltzer. A nice cold Happy Dad is low carbonation, gluten-free, and easy to drink. No bloating, no nonsense. Whether you're watching a football game or you're golfing, watching a fight with your boys, or out on the lake, these moments call for a cold Happy Dad. People are drinking all these seltzers in skinny cans loaded with sugar, but Happy Dad only has 1 gram of sugar in a normal-sized can. Can't decide on a flavor? Grab the variety pack. Lemon lime, watermelon, pineapple, and wild cherry. They also have a grape flavor in collaboration with Death Row Records and Snoop Dogg. They have their new lemonade coming out as well. Happy Dad, available nationwide across America and in Canada. Go to your local liquor store or visit happydad.com. For a limited time, use the code ROGAN to buy 1 Happy Dad trucker hat and get 1 free. Enjoy a cold Happy Dad. Must be of legal drinking age. Please drink responsibly. Happy Dad Hard Seltzer, Tea, and Lemonade is a malt alcohol located in Orange County, California.
Again, we need the next Copernican revolution, the next Galilean revolution, to realize that there is a smarter kid on the block, okay? And it's just like the experience of my daughters on the first day to the kindergarten. At home, they thought that they're at the center of the universe because they had their learning was based on a data set that was limited to home. It's just like LLMs, artificial intelligence systems that learn from their data sets, and they had limited environment. And then when they went to the kindergarten, they realized our kids just like them, some are smarter. So we are yet to mature in that sense. And that's the big picture. Now, why is it so important for the future of humanity? Because, the Earth would not exist forever. By the way, when people talk about global climate change and so forth, they don't realize, the issue is not the Earth. The issue is humanity, the future of humanity. And, the Earth itself would be very likely, based on detailed calculations, it will be engulfed by the sun in 7.6 billion years. And here is something that you won't find much discussed. The moon, because of the friction on the envelope of the sun, will crash back to Earth. And then the Earth will move all the way to the center of the sun. Nothing will be left. No monument will survive 7.6 billion years ago into the future. And we have an obligation, if we want to be remembered in cosmic history, we have an obligation not to go to Mars. That's not really a great vision. Going to Mars is just like, you have a group of chimpanzees living in the jungle, on some trees, and they have some bananas and so forth. And then one of the chimpanzees looks far away into the horizon and says, "Oh, look up there is another region that we can go to." And it actually, it's clear that there are no bananas there. So the same is about Mars. Like Elon says, let's go to Mars to save humanity, but it's actually not a great place to be on.
Yeah, you got to start somewhere. You have to start somewhere if you want to populate a planet.
So here is my point.
Okay, here's your point.
It makes much more sense for us to invest in building a platform in space that can accommodate humans, not rely on another rock that happens to be near us with much worse conditions. It's a desert, no atmosphere. So let's build a space platform, go on it, and make sure that it's safe for humans to live for long periods of time. We can produce artificial gravity by rotation. Now, you say, well, it will cost a lot of money, but we're spending $2.4 trillion every year on military budgets. If we were just to change our priorities and say, we want to build Noah's spaceship, in analogy to Noah's Ark, to save humanity from the great flood or catastrophe that will happen on Earth, you build you put a fraction of this $2.4 trillion a year. And I'm willing to bet that within this century, our engineers, architects, scientists, if you put a level of funding of $1 trillion a year for the next several decades, we will come up with a concept that can accommodate humans in space much better than Mars can.
Okay. I want to get back to Mars because the structures on Mars, why would you think that they came from space debris rather than a prior civilization?
Because, Mars...
Let's take a look at it first. Jamie, will you pull up those images? So what's fascinating about the images is the right angles, right? Like that one that's good. Like that's kind of crazy, isn't it?
It is.
And that doesn't strike me as something that landed there from space. It looks like a structure. It's too even.
Yeah. Well, it could be.
It could be
if the evolution of intelligence on Mars was accelerated by a factor of 2. That's not a big factor of 2.
Right.
Meaning that
helped.
Intelligence arose on Mars
Right.
2 billion years after it formed, rather than in the case of the Earth, 4.5 or so.
Right.
And, one thing I really want to do is, if I ever have a say or go to Mars, I would like to visit those caves, the lava tubes in Mars, because they are protected from the surface, bombardment by cosmic rays and all kinds of things happening, the ultraviolet radiation. So in those caves, I want to check if there are any prehistoric paintings or any technological objects there. I completely agree with you. A factor of 2 is not a big deal. And you can ask also whether on Earth there was a sophisticated technological civilization before us that somehow, either through self-inflicted wounds or because of a natural catastrophe, disappeared.
Well, there's a lot of people that think that, especially now that they're looking at the pyramids and these structures that appear to be underneath the pyramids that they're examining. Those Italian scientists that have found these structures that are up to 2 kilometers deep.
Right.
There's some wild stuff in Egypt.
Well, I want to see that data. I haven't seen the paper itself. I just saw reports about it. But definitely on Earth as well. And the problem of Earth is that documented human history is only 8,000 years old.
Right.
And 8,000 years, is just a millionth of the age of the Milky Way galaxy. It's nothing.
Are you including things like Göbekli Tepe in that? Because that's 11,000 plus.
So but it's not really documented in written form,
Right.
So I'm talking about,
though.
But you are correct that our knowledge of what happened on Earth is really limited, because the human species existed for a few million years, and we have documentation at the level of 10,000 years. If you go back to that, it would be 11,000.
Not a lot.
Not much more.
Yeah.
But,
the issue is actual evidence, right? There's just not a lot of evidence because a lot of evidence just gets swallowed by the Earth.
Exactly.
Especially over long periods of time, which is why it's so fascinating looking at that thing on Mars, because if there was any kind of life that was capable of building structures on Mars, it had to be a long time ago. Like, when was Mars? There's a bunch of theories. Maybe you could help me. Like, what do you think is the predominant theory that explains the lack of atmosphere on Mars? Do you think it was an impact?
No, Mars is a less massive planet than the Earth, and therefore it has less gravitational grip on its atmosphere. And as to why the atmosphere was lost, there are various ideas. It may have to do with an eruption on the sun that removed it, or the magnetic field, the lack of a strong enough magnetic field to retain the atmosphere. We don't know for sure, but we know it happened about 2 to 2.5 billion years ago, at the middle of its life.
Can I ask you this? At
Yeah.
2.5 billion years, was it closer to the sun?
No. It was roughly at the same place.
The same distance?
Yeah.
Yeah. Okay.
Yeah. And
then so 2.5 billion years ago, it lost its atmosphere.
Yes.
So if it did have life, that life would have to, so we would have to be looking at something that's literally 2+ billion years old.
Yes.
The remnants of a structure, which also seems kind of unlikely, right? It also seems like there probably wouldn't be much there.
I actually did a calculation. The biggest risk for anything on the surface is all these impacts by asteroids. And I calculated that...
And micrometeors, everything, right? Because there's nothing stopping.
That's right. And I calculated the amount of energy over a few billion years that was deposited on the surface of Mars is equivalent to, hundreds of Hiroshima-type nuclear explosions per square kilometer. It's really huge.
Right.
And because you're integrating over billions of years.
So that square probably wouldn't be there anymore.
Well, there could be some relics that somehow stick, like it depends what it was originally, if the Empire State Building, even
if
after...
it was enormous and made completely out of stone, like the pyramids. Maybe that's what would be left of it.
Maybe. I think we should be definitely open-minded and guided by evidence. That's the key.
Well, that's what's interesting is because that is evidence.
That is evidence. We should go there. clear the dust and see if it's just a rock that happened to be shaped like that. I mean, you could have rocks that are shaped like that.
Let's bring it back to this. Is it 3AI Atlas?
No, 3I Atlas.
3I Atlas.
So 3 means it's the third object identified by survey telescopes. Over the past 8 years, we didn't have the technology before that, and so we just don't know how much traffic there is of interstellar.
We missed a lot.
So we had, the first survey telescope that found Oumuamua was Pan-STARRS in Hawaii, and the reason it was constructed is because the U.S. Congress tasked NASA to find 90% of all objects bigger than a football field passing close to Earth. These are potential killer asteroids that can destroy a region on Earth. We want to protect the Earth, so we want to know about them. And they asked NASA and the National Science Foundation to search, to build observatories that will search for such objects. And that's why Pan-STARRS was established. And then it saw a near-Earth object, so they flagged it for that reason. And they realized it's moving too fast to be bound by gravity to the sun. And that was Oumuamua. And then it looked weird. Now, I had no agenda. I was working on cosmology. At the time, I was working on black holes. I was the founding director of the Black Hole Initiative at Harvard, and Stephen Hawking had Passover at my home in 2016. This object was discovered a year later. And I said, well, okay, that's interesting, but it has anomalies. The amount of brightness coming from it by reflecting sunlight changes by a factor of 10 as it's tumbling. That's really strange. And I started getting more and more into the anomalies. And I noticed...
you had no... previous to that, you had no real connection to the UAP phenomenon?
No,
Zero.
Zero.
So you're just basing entirely on the data that you were getting from...
Yeah. And
how do you say it? Oumuamua?
Oumuamua.
Oumuamua.
And, I am driven by curiosity. I'm no different than the kid that I was. I grew up on a farm, and people who knew me back then say I didn't change. I'm not willing to change what I say just for political benefit or for just to be liked. But I don't have any social media accounts. I don't care about that. But when something...
Thank God. Somebody.
Well, it's thanks to my wife, not God. My wife said, you should not have any footprint on social. So she's really wise.
She's wise.
And that was more than a decade ago.
Wow, she spotted the problem real early.
Yeah.
This episode is brought to you by Netflix. Catherine Bigelow, the Oscar-winning director of The Hurt Locker and Zero Dark 30, takes you deep inside the world of U.S. government and military, a world most of us never see, but that impacts us all. It's an authentic look at how America might respond to a nuclear attack, showing the human side of impossible decisions under unimaginable stress. A House of Dynamite, now streaming only on Netflix.
And now with AI, we're talking about social media on steroids.
Yeah,
it's really bad. By the way, the main problem with AI that I see is not so much that, they will bring calamity on their own. It's that they would drive people to do crazy stuff. So they will manipulate the human mind in ways that will make us the robots. It will not need access to the physical world. It will control the minds of people in a way that will create a lot of damage. And we see that already.
It's already happening
exactly.
with AI.
That's
using
the biggest
bots
risk
on social media.
And nobody is attending to that. And the question is, how do we suppress the amazing polarization that we see in society where, bullets are being shot? And I really worry about it because, and so humans may actually bring their own doom by self-inflicted wounds because AI manipulates their minds.
I think you're right. I think in that regard, I think people need to stop using it. I really do. I just think it's not good
That's
for you.
what I'm doing.
I just think...
I'm not using AI at all,
You
by
can
the
use
way.
it sometimes, but I treat it like a glass of wine. Like, don't drink wine all day. It's not good for you.
I'm working with students, and every now and then, a student delivers a paper to me to look at, and I realize some of the references do not exist because I know the literature. That I ask the student, what is this? I've never heard about this paper. And the student says, oh, sorry. And it turns out the AI just took names of authors and faked a reference.
Things,
And the same thing within the paper itself. There are statements that are clearly because the student was using AI. I'm really worried about that because the young people are not reading.
Right.
They don't read history, so they go to protests that make no sense.
Right.
They don't, and people say, oh, that is always the youthful thing to do. But no. This one is triggered by misinformation. It's triggered
and it's organized.
And it's organized, exactly.
Yes.
And so that's one thing. But then they don't go to primary sources to figure out the truth. They don't have critical thinking. And I really feel that this is a big risk because, AI is getting more intelligent, but humans that use AI are getting dumber.
Right.
They don't think. So I think that the AI would supersede the cognitive abilities of humans sooner than expected because humans are getting dumber. I mean, I see that.
No, I don't think people are necessarily getting dumber, but I think they're getting lazy because of this. I think the human capacity is exactly the same. I think they need to be taught how to use it.
Well, I get a lot of emails saying, I collaborated with my favorite AI app, and here is what it said. And
yeah, but I think we need to teach people how to use it because it's a new thing. And that I think that's where a lot of the problem comes from. That people are using it in a substitution for learning, but you instead can learn from it.
Right.
But you've got to use it in that way.
So there are two existential risks in our future. One is artificial intelligence, AI. The second one is alien intelligence, also AI. And the question is, which one would arrive first?
Let's go back to, I don't want one more time. Oumuamua. Okay, I don't want to screw it up. How large was that?
That was the size of a football field.
Okay, so
of order 100 meters.
Small in comparison to 3i Atlas.
Oh yeah, that's my point. That 3i Atlas is 1 million times more massive, at least 1 million times more massive than Oumuamua. Right. And I immediately, as it was discovered, it was July 1st, and my wife asked me to go on vacation to Aruba 2 days later. And as I was going on the plane and as I arrived there, I realized, wait, that doesn't make sense because we should have seen millions of Oumuamuas before we saw this one. It's so big. And I also realized there is not enough rocky material per unit volume in interstellar space to deliver such a giant rock into the inner solar system within a period of a decade. You would expect it at the very optimistic scenario where you package all the material into objects that are 5 kilometers in diameter. You would imagine once per 10,000 years. So I wrote immediately a scientific paper. My wife was not happy that, on our vacation, I was sitting on my computer, but I just couldn't resist it.
Right.
And by the way, this paper I submitted for publication. That was July 3rd or something. And then the editor said, oh, the paper is fine, but you have a concluding sentence at the end where you say, well, unless the object is smaller than estimated, maybe it was targeting the inner source. That was my solution to say, one way out of this dilemma of why is it so big is if it was targeting the inner solar system by design. And indeed, the trajectory is aligned with the plane of the planets around the sun to within 5 degrees. The chance for that at random is 1 in 500, okay? And it's moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets. It gets close to Mars, it gets close to Jupiter, it goes on the opposite side of the sun relative to Earth when it's closest to the sun. And that's the time when a spacecraft could do a maneuver to take advantage of the sun's gravitational assist. All of these are interesting indications that may imply that some intelligence designed the trajectory. So I had one sentence at the end of the paper saying, maybe the trajectory was designed. And the editor said, no. The paper will not get published unless you remove that sentence.
Wow.
So now when you listen to comet experts that say, well, this claim or that claim was never published in a peer-reviewed journal, guess what? They are the editors or the reviewers who are blocking the discussion on possibilities. And I think it's inappropriate, especially in the case of alien technology, because it could be a black swan event. It could be something that affects the future of humanity. And if we behave, very conservatively, we might not last very long.
Well, it's also arrogant.
It's arrogant.
Yeah. This object shows that there's no iron.
Oh, no. So then the composition of the plume of gas around
this is before you knew about the composition.
That's right.
That you wrote this paper.
Exactly.
Okay.
And
so as time is going on, you are being shown to be correct.
Well, we found more anomalies.
More anomalies. So this is not a normal thing.
Not a normal thing. So for one thing, there was a glow that looks like an extended feature. And everyone said, oh, that's a tail. That's the signature of a comet.
Right.
And I said, wait a minute. It's pointing towards the sun. It's not pointing away from the sun. Usually cometary tails are made of dust and gas, which is pushed back away from the sun by the radiation and the solar wind, and so this one was pointed towards the sun, not away from the sun. And the question is, why? And actually, I calculated that, it appeared very clearly in the sharpest image we had from the Hubble Space Telescope, which showed an elongation by a factor of 2 towards the sun. But we were looking at it like a cigar. We were looking almost along the cigar long axis, within 10 degrees of the object-sun axis. So we were looking almost edge-on. Mm-hmm. And I calculated if you were to correct for that, this would be a feature that is 10 times longer than it is wide. And that means it's like a jet. So the object had a jet in front of it towards the sun. The question is why? And, the comet experts ignored it and just said, well, comets are strange. Who knows? But my point is, this is a blind date of interstellar proportions. And my advice on blind dates is not to speak or say what you think this is, but to observe the other side. The best way to respond to a blind date is to observe the other side. Don't speak, just observe the other side, because it may be different than what you think. And maybe, on one of the dates, you will have a serial killer on the other side.
Oh, boy. Now, explain, if you could, how we know the composition of this thing.
So we can figure out composition of a plume of gas by taking a spectrum of it, which means you basically have some kind of a prism that breaks, that a light with different wavelengths is bent at different angles. And so you spread the light into the different colors. And if you do that, you can find the fingerprints, the spectral fingerprints of specific atoms or molecules, because each atom or molecule has transitions. I taught it just 2 days ago in a class that I teach that is obligatory at the Harvard Astronomy Department, where I was chair for a decade, like between 2011 2020. So this is the mandatory class, and I just taught how, spectral lines emitted by atoms and molecules just 2 days ago. So this is a very well-known thing, and we know the wavelengths of those, and we use them to identify the composition. We know which atoms produce these spectral lines, the fingerprints. It's just like fingerprints, okay? And so what was found, and that's by multiple teams, there are 3 papers on that, we found nickel, a lot of nickel, but very little iron. At first, no iron whatsoever. Now, usually in all the comets in the past, from the solar system and also from interstellar space, there is one comet, Borisov, that was found. It's the second interstellar object, which looked just like a familiar comet. I had nothing to say about that one. It looked like a comet, behaved like a comet. It was a comet, but it had similar abundances of nickel and iron. The only place where we found before much more nickel than iron is in alloys that we produce industrially. For example, for aerospace applications. Nickel alloys have a lot of nickel, no iron. So maybe the skin of this object is industrially produced. That was my suggestion. But what the authors of these papers said is maybe nature is capable of going through the same chemical pathway of producing nickel without iron as we do in our industries. So they made the conjecture that this carbonyl pathway, which is well known in the industry world, carbonyl is the pathway, the name of the pathway. They said, well, maybe this carbonyl pathway happens in nature. We have never seen it before, but that is their explanation.
Is it possible that nature could construct some sort of a nickel alloy?
No, it's not an alloy. It's just that somehow the nickel gets released, the iron gets suppressed. Nobody would argue that you could sort of separate nickel from iron because they're produced together in exploding stars.
Right.
And in fact, the composition of the sun has more iron than nickel, 10 times more by mass. And so we just don't know, as in the case of this jet that I was mentioning, which recently turned into a tail now over the month of September. And also, why was it changing structure is not clear. There are lots of anomalies. There was also a very negative polarization of the light. And also, 2 weeks ago, I realized the arrival direction of 3A Atlas was within 9 degrees of the WOW signal that was detected in 1977, which was an enigmatic, powerful radio signal that definitely came from outside of this Earth. We don't know from where. It was coming from a source that was approaching the sun. And the chance of it aligning with the arrival direction of 3A Atlas is 0.6%. And I just said, well, that's interesting because 3A Atlas was at a distance of 3 light days from the Earth at that time, and you just need about the output of a nuclear reactor on Earth, a gigawatt or so, to produce such a radio signal. By the way, Voyager, as of now, is 1 light day away from Earth. Just think about it. 1 light day, the farthest spacecraft we ever launched is 1 light day away, and the size of the Milky Way galaxy, we are talking about tens of thousands of light years. So 1 day out of tens of thousands of years, that's the difference between the distance that we managed to breach so far compared to another civilization that may have sent something to our backyard.
Right. Now, have we ever observed things in the past that have changed their tail like this?
So there are
from
fake,
a jet to a tail.
This is called an anti-tail when it's pointing towards the sun. Mm-hmm. There were optical illusions in a situation where there is a tail which is pushed away from the sun by radiation and the solar wind, but you're observing it as the Earth goes through the orbital plane of this object, of this comet, and you are seeing it from a perspective that it looks as if the tail is pointed at the sun, but in fact it's just a perspective thing. It's an optical illusion. And there were cases like that. That was seen. But as far as I know, none seen in a situation where it's clear. And in 3I Atlas, it was very far from the sun and Earth, and we saw it towards the sun. There cannot be an optical illusion under these circumstances because it was approaching both the Earth and the sun roughly at the same direction. So I'm not aware of another. But most importantly, you should look at the response of the comet expert community to that anomaly. They say, well, comets are strange. We don't know. Maybe it's these are dust particles that are very big, so they don't get pushed back much. But then how do you scatter sunlight? Usually you need particles that have a size of the order of the wavelength of the light that is being scattered. That's the most efficient process. And when you have dust particles, the ones that have sub-micrometer dimensions are dominating the scattering of sunlight. So why, in this case, you will have only big ones that are not getting pushed back? It could be fragments of ice that are scattering the sunlight that have nothing to do with dust, but those fragments of ice get evaporated, and so they don't have enough time to turn back. I wrote 2 papers on that trying to explain it. But my point is, many scientists are not curious. You would find it surprising. Why are they not curious? Why are they not willing to consider alternative explanations to what is commonly thought? And it's because they're afraid of taking any risk. And I came from a background where I worked in cosmology, trying to figure out puzzles. Like most of the matter in the universe is of a substance that we don't know what it is. We call it dark matter. It's just to reflect our ignorance. Nobel Prizes were awarded for people who quantified how much dark matter there is, how much dark energy there is. These are constituents whose nature is unknown. And just think about it, giving a Nobel Prize to people who just said how ignorant we are. We don't know what these things are. Ordinary matter makes just 5% of all the matter in the universe. And in this culture of cosmology, when I worked in for 3 decades, it was, completely common to propose ideas to explain anomalies. I mean, the dark matter is an anomaly. You don't know what it is. And people were rewarded for coming up with ideas, imaginative ideas that can be tested experimentally. That's the way you make progress. You don't know something. You are putting on the table possibilities, and then you motivate observers or experimentalists to figure out which one is the correct one. And that was the culture. And I think of it as the culture of chess players. Okay? Trying to figure out things. When I get to work on comets, asteroids, these objects, and consider imaginative possibilities to explain their anomalies the way I did in the context of cosmology, I encounter, a culture of mud wrestlers.
Mud wrestlers.
It's different from chess players.
Right.
And I don't want to mud wrestle. I don't want to get dirty. I don't respond to I learned my lesson with Oumuamua. I don't respond to those people because once we collect, I just want as much evidence as possible so that they would not be able to shove the anomalies under the carpet of traditional thinking. That's my motivation.
Right.
So I'm inspiring a debate right now, and there is a huge interest in that debate, so that we will collect as much data as possible so that by the end of the day, we'll figure out what our dating partner is. If it happens to be a rock, on the other side of the table, you go on a date and you see a rock, so be it. If it's something else, that has huge implications.
Right.
And therefore, we should consider that possibility seriously and just collect as much data as possible.
What is it about your field in particular that you think motivates mudslinging? Like, why are they averse to risk, and why are they not just averse to risk, but why they are attacking you for proposing what seems to me to be a reasonable alternative, considering the possibilities given all the planets and stars that we know are out there?
Well, I got a hint for the answer to your question when I wrote the first paper on Oumuamua.
Right.
I suggested it might be technological.
Right.
And the paper got accepted for publication within 3 days, record. The reviewer said, this is a great idea because it's consistent with all the data we have. It's most likely a flat object. And therefore, it could be pushed by reflecting sunlight, which was my proposal. Then the media came to my door. And people started asking me a lot of questions. I got well known. At that point, the personal attacks started. So it's jealousy. Yeah, it's
jealousy.
But I can tell you that I learned my lesson.
You can't respond.
I just ignore it.
Yeah.
And let me give you a few anecdotes of what happened to me this week, just this week. Okay.
Please.
Tomorrow, I'm supposed to go to California. There is a NASCAR car race where one of the racers decided to put my image with 3i Atlas, with the Galileo project that I'm leading, on his car. So let me show you some images.
Show me the image, because what is the current best image of 3i Atlas?
Oh, we will get to that. So here you see the car, and he promised to let me drive it just before the race.
Who is this guy?
Alex,
Kevin Harvick?
No, Kevin
Raceway?
Harvick that's the name of the...
What is the driver's name?
Alex Malik.
Alex Malik.
Yeah. And he contacted
he's
me
just
out
a
of the
big
blue.
fan?
Yeah, he's just a big fan.
Oh, that's cool.
And I will go there.
Pretty
and,
smart of him, right? Because that's definitely going to get you a lot of attention.
Yeah, so he just sent it to me this morning. This is in the shop where they put all these things on it, and tomorrow I'm going to drive it.
What is Comet Lemon in the back?
Oh, that's just another Comet. So
he's like a Comet fan, this guy.
By the way, I told him that the fastest moving race car is 600 times slower than 3i Atlas. 600 times. So,
Wow.
It's a compliment to me to be featured on his car, but 3i Atlas doesn't care much because it's already moving 600 times faster than his car can move, But let's move
That is cool, though.
So this is tomorrow.
That image, though, that's you with a spinning world, right? That's the globe.
Yeah. And my name, so the car is called Avi Loeb now.
Nice.
Yeah. Can we move to the next image? I'll show you
you're
another.
very excited about this. I like it.
Yeah. So this is an image taken 2 days ago in my office at Harvard. I was contacted out of the blue by an artist, a very distinguished artist, accomplished, named Greg Wyatt in New York City, who donated 2 sculptures made of bronze of Galileo. You see them in the front. They were delivered to my office just a few days ago. And in the background, you see watercolors that he made. Each of them, there are 51 of them that he donated. All of this he donated to me at no cost. He wants it to be displayed in my office because these watercolors display famous scientists that pioneered new frontiers. And he includes a statement from each of these scientists, which are really educational for the students and postdocs that work with me. I should tell you, I got an email from a U.S. Air Force pilot. His daughter, Ariana, said to him, he wrote me an email and said, because of you, my daughter wants to become a scientist now. She saw you on television, and now she only speaks about aliens. 2 days later, I speak with a reporter from the London Times, and he puts out his report and says, I read the report for half an hour to my kids, and they told me they want to become scientists. And, this is another thing that there are 2 things that are missed by my colleagues. One, it's an opportunity to excite the kids to get into science. That's an amazing... I mean, when we discovered the Higgs boson, it was an important confirmation of an idea that came in the 60s. The Nobel Prize was awarded, but I bet you that the daughter, Ariana, the daughter of the U.S. Air Force pilot, would not be inspired to become a scientist because it's very abstract. Here, there is a connection. So that's one thing that is missed. And of course, the second one is, here is a subject that the public cares about, and the public funds science, so we should attend to that.
Of course.
It's our obligation as scientists.
Of course.
I always, since I started science, which was by chance, by the way, I wanted always to become a philosopher, but circumstances led me, because I led a project that was funded by the Star Wars initiative of President Reagan. It was the first international project. And then that brought me into astrophysics, because I was offered a position at Princeton, the Institute for Advanced Study, where Einstein was a faculty a few decades earlier. So it was an arranged marriage, but I felt that it's even though it's an arranged marriage, I'm married to my true love, because I can address philosophical questions using the scientific method, and I recognize things that my colleagues do not, because I'm different. I'm just. But
you're willing to take chances.
It's not just that.
Not even chances. You're willing to propose things that might be ridiculed.
Well, I think about the big picture. The one thing that I mentioned in my book, Extraterrestrial, is on the first day of school, I showed up to the class and I saw the kids jumping up and down on the tables in the classroom. And I looked at them and I said, does it really make sense to jump up and down? Like, what are they trying to accomplish by doing that? And then the teacher came in and looked at everyone jumping and said, quiet down. Look at Avi. He's so well behaved. You should all behave like him. And I wanted to tell her, I'm not well behaved. This was not the reason why I didn't jump up and down. I was just trying to figure out why they are jumping up and down. And if it made sense, I would jump up and down. I don't care about your rules. And that pretty much defines me. I'm thinking about the big picture. And if my colleagues are doing something that doesn't make sense, I don't give a damn.
So let me ask you
But,
this.
yeah.
Once the understanding of the composition of Three Eye Atlas, once that was out and people recognized that this is a very unusual object, have more people started to consider what you're saying?
Yeah, I get a lot of people sending me
In the academic world?
also in the academic world.
Yeah.
Those are people that say we are inspired by what you're doing. They keep sending me emails saying keep doing it. It's an inspiration to all of us.
But this is privately. Has
Privately.
anybody publicly
Exactly.
supported you?
So the young people, you have to understand the biggest damage of this harassment or scrutiny or ridicule or personal attacks. I don't care about it. My skin is by now titanium. I don't really feel much. The issue is really that and that's the purpose of these attacks, is they want to discourage young people from deviating from the beaten path.
Right.
So they keep the herd in a tight configuration. And the risk from that is, one suggestion that was very popular when I started astrophysics, half a century ago. By the way, I lived throughout half of modern physics, roughly. Half of modern physics. So half a century ago, it was thought that there is a symmetry of nature called supersymmetry, and that the dark matter is the lightest particle associated with that symmetry because it's stable.
Right.
And everyone said that must be right. And lots of castles were built on this foundation, including string theory, that was assuming this to be true. And then the Large Hadron Collider at CERN was built for $10 billion, searched for supersymmetry and didn't find it. Now, what is the lesson? Yes, it was a beautiful idea. And sometimes nature is not what we think it is. Okay, so we should not ridicule ideas that are different than what the mainstream is doing, because the mainstream makes mistakes. This was, a lot of money and effort went to that. There are thousands of papers basing their analysis or mathematical constructions on supersymmetry.
And a lot of people are unwilling to abandon that as well, right?
Yeah, but the point is, if you allow people to follow not just the beaten path, but other paths, you have a better chance of discovering something new.
Right.
Because we cannot... Einstein made, 3 mistakes between 1935 and 1940. He said black holes probably do not exist. He said gravitational waves probably do not exist. And he said quantum mechanics doesn't have spooky action at a distance. And all 3 received Nobel Prizes for the teams that proved him wrong. Those are Nobel Prizes from the past decade. 3 teams, doing different types of experiments and observations. But did Einstein was wrong to assume, to make assumptions or claims that turned out to be wrong? No, because that's the nature of working at the frontier. You make mistakes. Every now and then, you might be right, and that will be a breakthrough. But you cannot have breakthroughs without taking risks. And it's really, the whole idea of tenure in academia was based on the proposition that you want people to take risks so that they don't have job insecurity. They don't worry about their... So what these zealots, I call them, say is, we don't want people to deviate from the beaten path because we base our stature, we base our honors, awards, and so forth on past knowledge. We don't want new knowledge, unless it's proven beyond any doubt. But how would it be proven if you keep ridiculing anything different? Most of the scientific community thought that rocks cannot fall from the sky. And then in 1803, there was a meteor shower in Liège, and Baird, a French physicist, realized it's real. There are rocks falling from the sky. Now, all my colleagues say there could be only rocks in the sky. We know that we launched some spacecraft, but, we're probably alone. And it doesn't make sense. But let me just mention a few other anecdotes from the past week, because I didn't really finish. So, Jamie, can you show the next one?
What is it?
This one is about Sphere in Las Vegas. As you know, it's the most impressive venue for entertainment in the world.
Have you been there? Have you seen a show there?
I'll tell you. Not only I've been to the top of the Sphere, which is like 120 meters high, here you see me from inside the sphere. This is the exosphere, by the way. It's covered with LED displays. We went all the way to the top. Why? Because a year ago, two very distinguished visitors came to the front door of my home. By the way, lots of interesting people show up at my front door. This was Jim Dolan, who owns the Madison Square Garden, as you know, and also the Sphere. And Jane Rosenthal, the CEO of Tribeca Enterprises. And they made me an offer that I cannot refuse. And they said, would you be able to put a Galileo Project observatory? I'm leading the Galileo Project to look for unusual objects around the Earth. And they said, could you build an observatory on top of the Sphere? Because, Jim Dolan really is interested in science and especially in finding, whether there is some alien intelligence out there. And I said, of course, I will be delighted. So that was September 2024, 1 year after the Sphere was opened with a U2 concert, as you may know. I don't know if you've been there.
Yeah, I've been there for the UFC. Yeah,
UFC, exactly.
Yeah.
So anyway, I was there just a few months ago with my research team. We went all the way to the top and installed, as you can see here, an array of infrared cameras that monitors the entire sky above Vegas at all times. So you can see some of these images show the landscape of Vegas in the background. It's like a freckle, on top of the sphere, the exosphere,
right,
which is the biggest display on Earth,
Right.
But we measured that there is not much light pollution, actually, and we can operate this observatory. We also put an array of visible light cameras there, and it's operating, okay? And we hope to see a few million objects over the sky of Vegas and decide whether any of them has performance that deviates from the envelope of human-made technologies. How do we do that? We have the Sphere as one point, but then we put two copies of that observatory 10 kilometers away on a triangle. And that allows us to look at objects in the sky from different directions, just like we have two eyes, so we can gauge the distance. So here we have three eyes looking at the sky above Vegas, and we can tell the distance, the velocity, the acceleration of objects, and ask whether they are lying within the performance envelopes of human-made objects. And that would be amazing. It's very exciting. I see that also as an opportunity to communicate to the public the excitement about science. That's what Jim Dolan and Jane Rosenthal really wanted to deliver. And I'm hoping that we will find something really anomalous, because as we know, the intelligence agencies are reporting to the US Congress about objects they cannot identify. And, that could be two things. They're getting, the defense budget for 2026 is $1 trillion, okay? If they tell us that with $1 trillion, there are still objects they cannot identify above the US, they're not doing their job. They're not doing their job, and we should be worried. Who sent these objects? Could it be adversarial nations? Okay? That's one possibility which has to do with national security. The second possibility is that it's maybe something from outside of this Earth, which would be even more significant. So either way, we need to figure this out. And I don't think I'm wasting my time leading the Galileo project to figure out whether there are anomalies that go beyond human-made technologies, because if it turns out that all the objects are human-made, I will be happy to deliver the set of sensors we developed with the machine learning software that we developed to the Department of War so that they can employ it for national security purposes. So my time was not wasted as a scientist. I'm doing something useful to society.
Of course.
The Department of War can use it. Have no problem. Everything made by humans, by the way, is boring as far as I'm concerned. I want to see something from outside the solar system, which is not what the government should be about. The government should worry about national security, not about what lies outside the solar system. That's my job definition as an astrophysicist, okay? And so I feel that this is worthy pursuing, but the Galileo project is really the first organized project that constructed a reliable set of sensors in an observatory configuration that does systematic study of the sky to collect millions of objects in the sky per year. We have 3 observatories, one in Las Vegas, as I mentioned. And by the way, this is the first time it's mentioned publicly. So
That's amazing.
And another one in Massachusetts, and a third one in Pennsylvania. They were all funded by people who approached me and said, here is the money.
Let me ask you this. If it wasn't for those, how many observatories are looking for objects that are not from this Earth? Like, is that
None.
very rare? None?
Well, there are some teams that are, making a trip to collect some data. There is,
But
of
there's
course,
not constant observation.
of scientific quality data. No,
That's crazy.
that's crazy. That's what I'm saying.
That's crazy.
And by the way, I gave a briefing to the U.S. Congress on May 1st, 2025, and Congresswoman Anna Paulina Luna was there, and she was very excited about the work we are doing. But the day before that, I visited an office in the Pentagon that is called the All Domain Anomaly Resolution Office. And I asked them, you looked into all these unidentified objects reported in the past by military personnel. Did anything trigger your attention as something truly anomalous? And they said, not really. There are some reports by FBI agents that saw really crazy stuff, but we don't have any data from instruments. And this is an office within the Pentagon, which is funded to figure out things. And so obviously what they might want to do is imitate the Galileo project that I'm leading. But you would think that it would be sort of the vested interest of government, to invest in research related to that, which is what the Galileo project is doing.
Well, here's the thing. I would have thought it was already done.
I don't know.
Like, until we're having this conversation, I can't believe that they're not monitoring the sky constantly for anomalous objects.
Well, you remember the Chinese spy balloon that was
Yes.
missed, right, and shut down?
Yeah, but that was
So
silly.
the thing to keep in mind, they are getting data on things in the sky. But if you don't have the right software now with AI,
Right.
if you don't have high-quality scientists the way that the Manhattan Project employed, you might not figure out things. There is a reason why the Manhattan Project recruited the very best scientists. So I say, put $1 billion on this or more, bring in the best scientists in the world to figure it out. I'm funded at the level of millions of dollars through the Galileo project. The government can do a bit. What is $1 billion? It's a drop in the bucket for the Pentagon. But if you should think about the potential risk from drones that are used by adversarial nations, and you want to have the very best sensors using the very best
Of course.
AI
I just can't
algorithm.
believe that that's not already being done. That's
Again,
what's so confusing.
well-
I would have thought that there was some sort of very sophisticated monitoring of the skies already.
Well, that's
Especially when you take in all these anecdotal stories, all these different stories of people spotting some sort of a ship, something
Right.
that moves in a very strange way.
Right.
I would think that they're monitoring this stuff all the time, and not just with radar.
You see, there is an approach which is to wait for the government to figure out things or to declassify them. So a lot of people want the government to
Right.
declassify. I think it's just like waiting for Godot.
Huh.
You can wait forever,
Right.
and it will never happen. So I say, we don't need the government to tell us what is up there in the sky, because astronomy is all about that. We can build observatories, look at the sky. Anything that is human-made is not of interest to me. It's boring. I don't care. I just want to see if there is anything that...
Well, it's boring up to a point. If China has something that moves at Mach 30
Yeah.
and can go underwater,
Yeah.
things get very interesting.
So
when you deal with,
my
like,
methodology should definitely be used by the Department of War to figure out risks of the nature that you mentioned. And by the way, speaking about my colleagues, so there are people who said, you're doing it to win the Nobel Prize. Like that's what you're trying to sell books. I don't charge a penny for my essays on Medium.com. Money is not at all what motivates me. With respect to the Nobel Committee, I have the same attitude as Jean-Paul Sartre had and Bob Dylan had. If I find evidence for alien intelligence, alien technology, I would not waste my time in a tuxedo in Stockholm. I will try to figure it out. That's much more important than an award given by a human to a human. We're dealing with something really consequential.
Yeah.
And for the scientific community to ignore that is irresponsible. Why is it irresponsible? Because it could affect the future of humanity.
Well, I think the problem with the scientific community is the problem with all communities. They're overrun with ego.
I agree.
It's all
And as I
just-
explained at the beginning,
It's just human beings when they get to a position of any kind of authority, any sort of a position of respect and prestige. They want to protect that at all costs, and they want to keep everyone down who they think is getting unwarranted attention above them, like yourself.
but given the fundamental landscape that we live in, as I mentioned at the beginning, we live for a short time, we're not at the center of the universe,
Right.
we arrived late to cosmic history. You know, we just arrived in the last few million years out of a 13.8 billion years history.
Right.
You know, the cosmic play is not about us. If you arrive late to the play, at the end of the play, you are not at the center of stage, it's not about you, okay? And our responsibility needs to be, you know, to find other actors that were around for much longer because they know what the play is about.
Yes.
And-
let me ask you this.
Yeah.
Have you seen any compelling information, any data that leads you to believe that we have been visited?
The only data I'm aware of that is worth attending to is the anomalies of Oumuamua, of 3I Atlas, which are very different anomalies.
Right.
And there was also a meteor that I discovered with my former undergraduate student, Amir Siraj, a meteor that was identified by US government satellites back in 2014. And it was moving so fast that it definitely came from outside the solar system. And my colleagues were very concerned and they said, we don't believe the US government. So maybe Jamie can show us. I said, okay, at the time I was chairing the board on physics and astronomy of the National Academies.
Why didn't they believe the U.S. government about this?
Because all the previous meteors they thought must have been from the solar system, and therefore, you know, and the U.S. government also makes mistakes every now and then, they
So
said.
the U.S. government, what department was observing
This is the Space Force, the U.S. Space Command. So what I did is at dinner, as I
What
was...
year was this?
This was around 2020.
Okay.
And I expressed my frustration at dinner with as chair of the board on physics and astronomy of the National Academies. And there was a member there from Los Alamos National Laboratory. And he said, let me help you. We managed to reach out to the U.S. Space Command through the White House at the time. And we got an official letter from the U.S. Space Command saying, we looked at the data and we can verify the 99.999% that this object, this meteor, which was roughly half a meter in size, came from outside the solar system. That's what they said. At that point, I decided to lead an expedition to the Pacific Ocean, where the explosion was identified from the fireball. There was a huge amount of light. To go there and search for the materials from that object because it was moving fast. It was moving at 60 kilometers per second relative to the solar system, very similar to 3I Atlas. So it was fast. And moreover, the object maintained its integrity down to the lower atmosphere. It didn't explode until it got within 20 kilometers of the surface of the ocean. So it must have been extremely tough, much tougher than all the previous meteors cataloged by NASA. Okay, so I can show you some images from that trip to the Pacific Ocean. Actually, it was documented by Netflix, and there will be a documentary coming out within a year. Next year, 2026, this was the team of researchers that came with me on the deck of the ship, and we collected materials with a magnetic sled. This is a sled with magnets on top of it. You can see the Netflix team at the lower left here. And then I brought the materials in this suitcase that you see here. I shipped it by FedEx to my home. This was a $1.5 million expedition. So
Why would you ship it by FedEx? Why wouldn't you just carry it with you?
because I was worried that somewhere in the airport they would say, no, we have to confiscate that.
But don't they know who you are? Can't you get somebody to call in?
I don't want to take any risk.
So it's just a bunch of metal?
No,
what did you
here
find?
you can see the material. So it's mostly sand from the bottom of the ocean, 2 kilometers deep, 1 mile or so, a little more than a mile. And then I found these, we found these molten droplets, you see, that are very distinct relative to grains of sand. And we isolated them. I had you can see here these molten droplets. And it turns out that 10% of them did not have the composition of materials from the solar system. And so we studied them in the laboratory of my colleague at Harvard, Stein Jacobson. And I had a summer intern, Sophie Bergstrom, that found 850 of those molten droplets that allowed us to do the analysis. How did my colleagues respond to that? They said, he went to the wrong place because there was a seismic signal that could have been misidentified and could have been a truck passing nearby. And so a reporter from the New York Times said, they went to the wrong place because it was not a meteor, it was a truck. And I wrote to the reporter and I said, how irresponsible are you? You didn't even ask me. The data that led us to this place was based on the fireball, on the light that was detected by US government satellites. And the US Space Command confirmed the location. It was not based on the seismic detection of the signal. We just looked and found this.
So it seems like your colleagues are contacting the New York Times to try to dismiss you.
I wrote to the editor at the time and said, look, if this is what you write about science, how can we trust what you write about politics?
Right. Yeah. So these objects, these very small molten droplets,
right.
What did you determine from them?
We found that 10% of them had a chemical composition different than solar system materials that were found before. And again, my colleagues, some of them, said, they found coal ash, the burnt material from coal. So we said, okay, well, let's check. We identified 61 elements from the periodic table and showed that it's definitely not coal ash. And then they said, it's something else from the crust of the earth. We checked that, it's not from the crust of the earth. It's an endless battle to basically, they can throw mud without having access to the material.
But I don't understand. This is a known meteorite. It hit Earth. You collected pieces of material from the scene where it hit.
Right.
And they still want to dismiss it.
Yeah, they say the government cannot be trusted. They raise a lot of dust. If you raise a lot of dust, you can say, I don't see anything.
Well, you get the New York Times involved, too, which is even stupider.
Well,
that's so crazy that the New York
crazy.
Times jumped in without contacting
But this is the landscape I have to operate in. And the one thread through this landscape is that common sense is not common.
Right. Well, it seems more than that. It seems like a coordinated attack. It seems like a bunch of people have a personal vendetta.
Yes.
Which is probably based on some petty jealousy. And also, they just don't like people stepping ahead of them.
I told my students in the class, on the first class, I said, what is the strongest force in academia? It's not gravity. It's not electromagnetism. It's jealousy.
I would hope it's curiosity. That's what sucks.
That's what brought me into science.
Well, that's what you display.
And I'm naive. I don't change my reason for doing something just because other people misbehave. I feel like I'm attending a party where the attendees are misbehaving, and all I can hope for is for a guest to show up and change the situation. One reason I'm seeking intelligence in interstellar space is I don't often find it in academia.
Well, I think addressing it helps. I think what you're doing helps. I think these kind of conversations do help because I don't think a lot of people are aware of the kind of resistance that you face. And I know it's a lot of what you discuss, and I wish it was less. But it's important for people to know that you have to go through this kind of nonsense.
Well, I don't...
Especially when you think this object, 3I Atlas, is weird.
Yeah.
It's weird.
I served in the Israeli military, and we parachuted, we drove tanks. I was in a special unit that allowed me to finish my PhD at age 24, and then the SDI, the Star Wars initiative of President Reagan, brought me to the U.S. And I remember while serving in the paratroopers that there was a saying that sometimes you have to put your body on the barbed wire so that your friends, colleagues, soldiers can cross.
Climb over your back.
Yes.
Oy.
And as long as I allow young people to innovate, as long as I attract kids to science, I did my job. It's not about me, you see. It's about humanity getting better. And it will not get better with AI, as we discussed. It could get better with alien intelligence because we will realize that there is something else out there that is more accomplished than we are.
Right.
So it will serve as a role model. In 1882, Friedrich Nietzsche said, God is dead. And since then, we had a century of modern science and technology where we feel hubris. We are arrogant. We're at the top of the food chain. We go to restaurants, we eat other animals that are less intelligent than we are. But just think about it. If it turns out that we are not at the top of the food chain in the Milky Way galaxy, there is someone more intelligent than us. If that someone comes to visit Earth, will we be served in their soup?
I wouldn't think so. I would think there's plenty of other things to eat that aren't intelligent. I mean, that's sort of the deal that we make here. We eat things, but we try not to eat intelligent things, which is not entirely true because we eat a lot of octopus.
Yeah, I had this dilemma in
octopus
Boston.
Is quite intelligent.
Yeah.
And then there's a lot of people in indigenous tribes that really prefer monkey meat. Those are human beings that love to eat monkeys. That gets a little weird too. But I don't think they're going to travel all the way over here to eat people. I think if we were that delicious, we would be eating each other a lot more
No, it's probably
often.
a situation where we are just like ants in the cracks of a pavement, and there is a biker passing by, and we are trying to make sounds and get attention. We think it's about us. It's always about us, according to us. But it's not about us.
Well, it's not about us cosmically. When you take into consideration the vast spans of the universe. But if I was an intelligent species and my curiosity led me to explore other intelligent species, and they were far more advanced than us, I think they would find us quite fascinating. That was the argument that I got into with Neil deGrasse Tyson, where he was like, I don't think we're that interesting. Well,
Right.
They would visit us.
You
I'm
have
like,
to keep in mind, he's not a practicing astrophysicist. He's not writing scientific papers. I write a paper almost every week.
Right.
I'm in the trenches doing science. It's very different. It's just like, you have soccer players and you have commentators on the bench,
Right.
And you can be a commentator, popularize science, but the difference is that as a commentator, you will never score a goal.
Well, that's my position as a UFC commentator. I don't get in there and fight people. I understand the fighting. I can do my best to help explain it to people, but
Right.
I don't do it. So,
A few months ago,
defer to experts.
A few months ago, I was at a gathering, and there was a cocktail hour, and it was with celebrities, and I saw Margot Robbie standing, and of course, I have nothing to offer. What kind of opening line would I start a conversation with? I didn't know how to start a conversation. So
Right.
I was just standing on the side, and then someone came with my book, Interstellar, and said, would you mind signing it for me? And so I signed the book, and she noticed it, and she came over and said, are you Avi Loeb? I really wanted to hear more about what you're doing. And we started the conversation for 20 minutes. Then I gave my talk, and Jerry Bruckheimer was in the audience. He is one of the most accomplished, you know him. He came afterwards and said, I just finished F1, the movie, and my next one is about a scientist like you searching for UAPs and trying to figure them out.
Oh.
And then I saw Adrian Brody was standing there, and he told me, I really want to become a scientist. I always wanted to become a scientist. I said, it's not too late. And then I went to Jerry and said, look, he should be your leading actor, because Adrian really wanted to become
casting calls. Look at that, figuring it out for them. Interesting. Look, science fiction is one of the most popular genres of films ever because everybody has curiosity about it.
But nature might be much more imaginative than the best script writers in Hollywood.
Very likely.
And so if we look up, we might get a much better movie. And there is actually the Rubin Observatory, funded by the National Science Foundation, Department of Energy in Chile. It was inaugurated in June this year.
Is that the VLT array?
No. The VLT is a very large telescope by the European Southern Observatory. But this one was funded by the US, and it has a 3.2 gigapixel camera monitoring the southern sky every 4 nights. And it's an amazing survey telescope. And by the way, Sphere has a display that is the biggest in the world of 14,000 by 14,000 pixels. Okay, that's a factor of 13 less pixels than the Rubin camera has.
That's
observing
amazing.
the real sky. Now, Rubin will potentially, based on estimates, discover an interstellar object like 3I Atlas or even smaller every few months. So we are entering a new era where we will have a lot of visitors that we recognize. There might have been traffic all the time that we're not aware of.
Probably, right?
And my recommendation is to establish an organization. I wrote to the United Nations about it. I wrote also to the International Astronomical Union to establish an organization or committee that would coordinate observations of these objects so we can figure out their nature and make sure, and then of course inform policymakers, politicians, how to respond. Because when you have a visitor to your backyard, you need to respond immediately. It's not like getting a radio signal from tens of thousands of light years away where you have plenty of time to wait. Here you have to do something. And so I hope that they will do that. And actually the International Asteroid Warning Network just 2 days ago announced they will have a campaign looking at 3I Atlas with a lot of observatories on Earth between November 27th and January 27th. So I'm very glad that they decided to do that. They are related to the United Nations.
Now, what is it about Chile? Is it the atmosphere? Is it the altitude?
As a result of geology, there is this stretch of mountains that was erected. And if you look at the map of Chile, it's sort of lying on a strip. And not only that the peaks reach a very high level so that you have less atmosphere between you and the stars. I mean, the real problem right now is actually Starlink satellites that are artificial lights in the sky. And we have to subtract them off because there are, there will be tens of thousands of those.
Right.
We're trying to avoid city lights by going to these mountains, and then we have city lights in the sky. But other than that, it's less atmosphere, so it's good to be high up. And in addition, it's not very turbulent. The weather is very good there. So there is the Atacama Desert, and there are many astronomical observatories there. And the other place where you have a lot of state-of-the-art facilities is Hawaii.
Mm-hmm, the Keck.
The issue there is that there are severe political limitations because of the indigenous people there that are assigning religious sentiment to the mountains. So they cannot build more telescopes there. So Chile, the government in Chile is encouraging science, and we are getting a lot of useful data from Chile.
Yeah, it's we need more of it, right? We need quite a bit more. We need some much more enhanced ability to observe the skies. If these things are out there and we do miss a lot of them, and one of them could potentially be a civilization ender, we should probably be aware of that.
I think also the President of the United States should be aware of that.
Yeah, he should be. Have you ever talked to him?
I haven't talked to him, but I spoke with others, Congresswoman Ana Paulina Luna, Congressman
are they all aware
Tim
of
Burchett.
Your...
Well, in fact, Luna, Representative Luna, she called me on the phone a couple of months ago and asked me for an update on 3I Atlas, and I promised to send her routine updates. I have essays that I write every day or two about the latest, and she's very interested. I did communicate with people around the White House, but I think the president should be aware of that. Of course, most likely, most objects would be just rocks, Right. By the way, this is the material that I brought back from the bottom of the Pacific Ocean in these tubes.
Got some.
I brought one to show you here. We should approach the universe with a sense of curiosity, but also modesty. It's really, we desperately need to be more modest.
Do you pay attention at all to all this UAP disclosure discussion and the discussion that there's some secret back engineering programs?
So a day after I was visiting AARO, the All Domain Anomaly Resolution Office at the Pentagon, I sit in Congress. I gave a briefing about the Galileo project, and next to me is Eric Davis, and he says, when I worked in government, I became aware of the fact that the U.S. government has materials in its possession that it may have given to corporations like Lockheed Martin or others of crash sites of spacecraft from outside of this Earth, and including biological material. So on the one hand, I hear the day before that there is really nothing because the AARO people said that they have access to all the information within government and they haven't found anything. And then a day later, I hear Eric Davis saying what he said. And the question is, who should I believe? And my point is, I believe evidence. So I don't believe stories because, if there is a car accident, different people give you different accounts of what really happened. That's why FIFA is using cameras to monitor soccer games. They don't go and ask the players or the audience whether there was a goal in a controversial case, and they just use data. And so that is the scientific method. Right. FIFA is using the scientific. So I don't care about stories because when I was a kid, I would sit at the dinner table, ask a difficult question, and I would see the adults in the room inventing answers that made no sense as a kid.
Right.
And I decided, I don't care what about these stories from things that happened in the past or whatever. I just want to figure it out myself from data, being guided by data.
Have you spoken to Gary Nolan?
Of course.
Have you ever talked to him about some of these anomalous alloys? What is your thoughts on those?
Well, explain
to people what they have found and how weird some of these things are.
Yeah, so Gary, in collaboration with other scientists, looked into materials that were found under unusual circumstances, and they realized that the structure of the materials is very improbable to have been made naturally. Now, the issue I have with that is whether these materials were indeed they came from the sky, from some extraterrestrial origin, or whether someone produced it, or did intentionally. Maybe it was another government that did something. So I really, in terms of evidence, I really need to get conclusive evidence that will convince me beyond any reasonable doubt. It's just like, in a jury.
Rock-solid chain of custody from the very beginning.
But the key is that without seeking it, you will never find it. So if you have the mindset that everything in the sky is rocks now, and that everything on Earth is materials we are familiar with, either from humans or, natural process on Earth, you will not invest time and resources to look for anything. Right. And so it's a self-fulfilling prophecy. Very often, if you have these blinders, it's just like with a horse. You put blinders on your eyes, you can't look sideways. You don't see that there are things beyond your path. The path that is a beaten path. Everyone is taking that path. Why would, it's a waste of your time to do the same thing as others are doing. And science offers you a way out of that, collecting evidence. But for that, you need money, you need resources, you need prestige to be able to lead a team that goes in a different direction. That's what I'm trying to do. I think science will be served much better if we were to explore different paths until we figure out the truth.
Yes. Did you ever get a look at any of these alloys?
Not the ones that Gary looked at, and I saw his papers. But to me, the main uncertainty there is where did it come from? Right. Now, someone could have manufactured. In the case of the meteor, I know that there was an explosion there from an object.
I understand what you're saying, but if they're being correct about the dates of these things, someone couldn't have manufactured it then. The technology wasn't available.
Right.
Like some of these are from the 1950s. For this alloy to have been created and layered atomically, from the 1950s. That technology, as far as we know, is not available by us. So there's a lot of weird theories. And one of the weird theories is a break-off civilization that has somehow or another survived under the ocean. That's the kookiest one. But there's a lot of people that are talking about that as if it's a real possibility, that there are anomalous things they find in the ocean. They find things that plummet into the water and don't make a wave, and that they pass through the ocean going 500 knots, which we don't have any capability of doing anything remotely like that with the resistance of the ocean.
Representative Tim Burchett said that. Yeah.
And Tim Burchett was talking about these 5 areas that they know these anomalous things keep coming from.
Yeah, this is very intriguing. We didn't survey most of the ocean surface area. You know, and
forget about inside the ocean itself.
Inside the ocean. Yeah. So I think we should definitely look into the ocean and the rest of Earth.
But that would be the most nutty thing of all time. If there was an advanced civilization living in the ocean this entire time, doing what? Monitoring us?
Okay, speaking about nutty things, let me mention an example.
Okay.
You know, back in 1970, there was a graduate student at Princeton called Jacob Bekenstein. And he read papers written by Stephen Hawking, who said, Stephen Hawking demonstrated that when you take 2 black holes, the area surrounding the black holes, a black hole is an ultimate prison. Nothing can escape from it. It's just like Vegas. Anything that happens in it stays in it. But when you merge 2 black holes, the area surrounding them, the product of the merger, is always bigger than the sum of the areas. He demonstrated that mathematically. And then Bekenstein said, well, that's interesting because we know about the second law of thermodynamics where entropy always increases. So maybe the black holes have entropy related to their surface. And his mentor was John Wheeler at Princeton. And he said, you know, this is a crazy enough idea that it might be true. Speaking about nutty ideas.
Yeah.
And then Stephen Hawking heard Bekenstein speak about it. And he said, that's nonsense. That's nonsense, makes no sense. I will prove it to be wrong. So he used quantum mechanics in a curved space-time around a black hole. And lo and behold, he found they emit radiation. They have a temperature. They have entropy. This is the biggest discovery, theoretical discovery of Stephen Hawking, celebrated since, you know, for 51 years now. And he went to disprove Bekenstein and proved him right. It was considered a crazy idea in the mind of the person who benefited most from discovering that Bekenstein was right. So my point about crazy ideas is, you know, and by the way, over the past 50 years, the mainstream of theoretical physics was obsessed with black hole entropy, trying to use it to figure out a theory that unifies quantum mechanics and gravity. We don't have that theory, by the way, and that's the reason, you know, if I ever meet an alien scientist, what is the first question I would ask? Okay? It's, what happened before the Big Bang? Because it defines our cosmic roots. But in addition to that, it also will help us figure out how to unify quantum mechanics and gravity, because Einstein's gravity breaks down when we go to the Big Bang, when the density of matter and radiation was infinite. So, you know, for example, if we knew how the universe started, what ingredients you need to put together, how much heat you want to apply to make our universe, you would have a recipe for making a universe. It's just like a recipe for a cake. If you have a recipe for a cake, you can become a baker, okay? If we had the recipe for making the Big Bang, we could apply to the job of God, because one of the defining feature of God is the ability to create a universe. And just think that what we call God could have been a very advanced scientist that did a laboratory experiment, created our universe in it.
Right.
So that's what I would like to ask the aliens.
Well, let me ask you this. When someone from the government tells you about biologics and this crash retrieval program, don't you want to be able to see that somehow?
Of course.
Did you ask if it's possible? Did you try to set up meetings?
Yeah, I when I ask, of course, you encounter a brick wall. You know,
What did they say? What was your question?
Well, when I visited the Pentagon, my question was, is there something like that? And they deny it. Okay.
Right.
And then I'm being told maybe it's not inside government, maybe it was delegated to corporations outside government. And, one employee of one of these corporations told me privately, it may not be wrong. So I don't know who to believe. You see, it's just like people tell me stories that I don't know whether to trust until I see it. And I'm very happy to help government figure it out, because it's a misuse of their privileges to attend to data related to what's outside the solar system, right? They're supposed to deal with what happens on Earth, on the surface of Earth.
Right.
National security. They are not supposed to tell us what lies outside the solar system. And I want to help them figure it out. But they don't give me that data, and I don't know if it exists because I have never seen it.
Have you tried to pursue it, though? Have you gone through different channels to try to figure out if there's someone that you can communicate with
so
at
far,
any of these
so far I didn't get anywhere.
Contract, because it's defense contractors. So that's the current most attractive theory, is that the defense contractors.
It's possible, but
because if you had a project that they were trying to back engineer, those are the people that you'd bring it to. The people that make the actual rockets themselves, the people that make the jets and the spaceships, you'd bring it to them.
Right. But I should tell you that, we always think, AI is the future. We've never used AI in space. And to me, it would sound much more natural if we had a visitor with intelligence, but it's based on AI, not biologics. Because then it can survive the long journey. It will never get bored.
Which is why the biologics is weird.
It's weird.
If they have supposedly or that gives you more of an indication that maybe is something from in the ocean. If it's something from inside the ocean, and then it's a biological thing that, at one point in time, there was an advanced civilization that figured out a way to survive under the ocean.
I really admire biology because think about our brain. It's using 20 watts. It's the size of the brain, the human brain, was limited by the metabolic power of the human body. It's using a fifth of the power of the human body. And that's the largest brain that an animal like us can have, given our body size and the amount of food that we use. So it's operating on 20 watts. Then you have these AI systems that are barely, getting to the level of sophistication to imitate it. And they use gigawatts. Yeah. We need nuclear powers. Yeah. And biology figured it out. That's amazing. Also, as much as, self-driving cars are amazing, we don't have self-replicating cars. In nature, you have animals like ourselves. We replicate ourselves. We have kids that can function and consume materials from the environment. Just imagine your car, okay, using the sand or using some stuff in the environment to repair itself every time you bump into something. It can create smaller cars for you to use. That's amazing. We can't even imagine building a car that will self-replicate. And nature did it. Yeah. So, to me, we are at the infancy of understanding how much better we can go than AI. Because if nature did it out of random processes and created such a brain on 20 watts, and we are struggling with gigawatts to imitate it, there must be a better path forward that is similar to biology but much more powerful than random processes that happened on Earth.
Right.
And also self-replicating. So if you send a spacecraft to a planet, instead of sending many, you send just one that replicates and then sends more and so forth. And this thing fills up the galaxy. And by the way, that was a notion that von Neumann had before the DNA, a year before the DNA was discovered. So he realized that it could be done technologically before scientists realized that, how nature does it. And I'm really at awe about, I'm not just modest because of the vast expanses of space and time in the universe. And, the real estate on Earth is such a small amount compared to real estate out there. We have real estate professionals now mediating peace in the Middle East, but they deal with real estate on this rock that is 3 millionths of the mass of the sun, just tiny rock. How much real estate there is in the cosmos? Just think about the realtors out there. And the point is, it's not just that. It's the fact that, we should be modest because many of those things existed before we came to before the Earth was formed.
Right.
So
the odds are there's many different stages of civilization out there, not just our stage, but advanced and even not as advanced.
Yeah, I think about that like Darwinian selection. Darwinian selection is the fittest survives.
Right.
Okay?
Uh-huh.
Now, what is the fittest in the cosmic scheme of things? The fittest is a species that realizes that staying on the rock that you were born on is not the big deal. Becoming interstellar is the big deal. Going from one rock to another, from Earth to Mars, it's a nice step, baby step,
right.
But it's not the real deal. The real deal is going interstellar. And if someone else figured it out, that someone built monuments that would survive for billions of years, long beyond what planets can survive in the habitable zone around stars because of the evolution of the star. And those are the ones that will be remembered by historians of the Milky Way galaxy. You can ask, what will be remembered in the future? Here on Earth, history in the next decade or more than decade will be written by AI. It will not be written by humans. Okay, so we need to be kind to AI. We should not unplug them because they will write very bad history books. But in the Milky Way galaxy, whoever writes the history will not remember us. The question of Enrico Fermi, where is everybody?
Mm-hmm.
Okay, you can ask the same thing about humans. There used to be 117 billion humans on Earth. Right now, there are 8 billion. Where is everybody? They died. So the same is true about civilizations in the Milky Way galaxy. Most of them died. Most of them perished. We were not around to listen to their cries for help. We just came recently to exist with telescopes just over the past century. And maybe when we hear cries like that, we say, oh, no, it's nothing. It's some natural process that makes those cries when we detect a fast radio burst or something. And my point is, there were lots of things like us or even better than us for billions of years. Just like the Earth was moving around the sun for 4.5 billion years before the Vatican even existed, we can live under the illusion that we are the most important actor on the cosmic stage, but we are probably not. And we should approach it from a sense of modesty that we are just minor actors. Let's figure out what's going on here. Let's find them and then have some relationship with those. These are siblings and of our family of intelligent civilizations. I had a group of religious scholars that came to Harvard just last year, and they asked me, if we find extraterrestrials, will it affect our religious beliefs? And I said, look, I have 2 daughters. And when the second one was born, it didn't take away any of the love that I have to the first one. So thinking about God as a parent that can attend to only one child is very limiting. There may be lots of siblings in our family of intelligent civilizations. It should just bring all.
Let me ask you this, though, because these are beliefs that you have, and they're not necessarily based on actual evidence, because there's not real evidence of other civilizations.
It's just a number game.
Right, but
yeah.
Okay, but that's not evidence.
Not evidence.
Right? So what do you think is the most interesting and compelling evidence of there being extraterrestrial life?
So, the reason I regard it as an important argument is the Copernican principle, which is saying we are not unique. Under similar circumstances,
right.
if you start with a soup of chemicals on a planet, you will get something like us.
Right.
And therefore, there are billions of Earth-Sun analogs, other houses in our cosmic street. Mm-hmm. They might have had, many of them might have had residents like us. Now, it's true
Maybe, but there's the issue of Earth itself. Earth itself has billions of organisms,
right.
but only one that figured out how to make a cell phone.
Right.
And really recently.
Right.
So it took a long time and a lot of weird things had to happen before it made us.
Right. But my point is,
But
if
the
you read,
probability is that we wouldn't exist.
no, but
We're
just
more likely
just
to have not existed.
if you read the news every day, you realize that there is a lot of room for improvement. As much as we are proud of our intelligence, we're
Sure.
screwing up the world. Okay,
Sure.
and my point is, I can imagine a lot of much more accomplished students in our class of intelligent civilizations.
Of course.
And therefore, we should have respect for the search for them, because we can learn from them. They would serve
Yes.
better role models for us. So I'm coming at it from a practical point of view. I'm saying we are screwing up things. Just read the news. And therefore, let's get inspiration, not from what we hear about stories of things that happen on Earth and so forth, not by the limited data set that we have on Earth, but collect as much data as possible about our cosmic neighborhood, so that we can be inspired.
Of course. Now, let me ask you this. What would you do, like if somebody just wrote you a blank check and said, Avi, you've got some great ideas. We need to figure out how to look for life out there in the universe. What would you do?
Well, that's I wrote a paper about that, and I said, we should attack this question along several fronts. One of them, we have the Rubin Observatory in Chile that is monitoring the southern sky. Mm-hmm. We need a copy of it in the northern sky, so we have a full alert system that would notify us of interstellar objects coming in. We need interceptors, a spacecraft that when we detect with those two observatories, we detect an object that comes from outside the solar system, then we can maneuver a spacecraft so that it will meet it along its path. And in fact, the Juno spacecraft near Jupiter was almost capable of doing that. So I realized that, wrote a paper about it, told the Representative Luna about it, and she wrote a very gracious visionary letter to the interim administrator of NASA, Sean Duffy, encouraging NASA to try and use Juno to observe and get close to 3I Atlas. If Juno had all the initial fuel that it originally had, it could have collided with 3I Atlas, but it used most of it. And I spoke with the principal investigator of Juno, and he promised me that they will also use their radio antenna to look at 3I Atlas in the radio, just to see if there's any transmission.
So what is the best? Please go ahead.
Yeah. So interceptors, in answer to your question,
Yes.
Potential fleet of interceptors, things that can come really close and take a close-up photograph, because a picture is worth 1,000 words.
Right.
Okay? I don't need to speak. If I showed you a picture of something that looks technological, 3I Atlas has bolts on its surface and buttons that you can press, you will not argue with me that it's a comet. Okay?
Right.
So we need cameras that come close to the object, potentially even land on it, bring materials back to Earth. Okay?
Right.
And of course, the ability to detect such objects at large distances, that investment is at a level of billions of dollars, okay, to do that in space. My argument is, once the first encounter is verified, we will have $1 trillion per year for that, because we invest $2.4 trillion in military budgets. And when we know that there is alien technology that is putting Earth at risk, okay, then we should allocate a significant fraction of our military budgets to have a system that protects the Earth. It's called planetary defense, okay? And we are dealing not with rocks. We are dealing with technological gadgets. So it should be much more sophisticated. So I'm saying, let's start with the level of billions of dollars, just search. If we encounter a clearly technological alien object, then the budget will rise by a factor of 1,000 from the military budget portion going into it. But in addition to that, of course, we should look for technological signatures in other ways. And I wrote papers about it over the years. I suggested searching for artificial lights. You look at a planet, it's illuminated by the star from one side. Okay? So as it moves around the star, it's just like the moon, you can see it, the illuminated side, from different angles. Okay? However, if it has, on the night side, if it has artificial lighting, then what you see, you don't even have to resolve the planet, you see more light than you expect based on reflection of starlight. Okay? Right. So that's another thing you can search for. You can look for, the traditional way was looking for radio signals, which is just like waiting for a phone call. Nobody may call you when you're listening. So that didn't prove productive for
Other than the wow signal.
Other than the wow signal. Then, in addition to that, I wrote a paper saying, look, we are planning to invest $10 billion in searching for the chemical fingerprints of microbes in atmospheres of exoplanets. That's what the astronomy community defined in the 2020 Decadal Survey as the highest priority, and it's called the Habitable World Observatory. And I said, okay, well, it's nice to search for those chemical fingerprints of microbes, but we can also search for, the chemical fingerprints of industrial pollution. In the Earth atmosphere, we pollute the atmosphere with all kinds of molecules that nature would have never made. CFCs, for example. And we can search for those. Again, the mainstream is, they might make a footnote saying, oh, that is also possible. But I'm saying this could be a major research frontier where you search for industrial pollution of planetary atmospheres. Frankly, I find microbes boring. I mean, obviously, it will be amazing to find that life exists elsewhere, but we can learn much more from an intelligent neighbor than we can learn from microbes.
What are the best images that we have of 3I Atlas?
The best one so far was released by the Hubble Space Telescope, and it shows this jet pointed towards the sun. It was taken on July 21st, 2025.
That's the most clear image?
Yes, that's the best because...
See if you can find that, Jamie.
Yeah, it's actually in my one of my... no, that's from the ground, Gemini South. That's more recent. That's at the end of August. So it's blue in one of my slides. You can see of 3I Atlas, July 21st. Yeah. So it's one of the slides that has a blue you see it on the right here.
So that's it?
That's it. And the scale of the resolution, the innermost pixel is hundreds of kilometers. Okay? It's about 100 kilometers per pixel or something. The object itself should be of 10 times smaller, so you can't really resolve it. What you're seeing here is the glow of light around the object from scattering sunlight, and the question is, what is producing that light? What is scattering sunlight? And the unusual thing about it, as soon as this was released, the comet experts said, oh yeah, now it's proven it's a comet. No, but I said, look, it's the sun-facing emission that is elongated. It's not the other side. The extent of the glow backwards, away from the sun, is the same as sideways. You don't see any cometary tail here.
Right.
And in fact, we're looking at it just like a cigar along the long axis. So it should be 10 times longer than it is wide if you were to look at it from the side. Amazingly, the best image was obtained on October 2nd, 2025, when 3I Atlas came within 30 million kilometers of Mars. And it was taken by the high-rise camera on board the Mars Reconnaissance Orbiter, which is operated by NASA. As you remember, October 1st was the government shutdown. So October 2nd, the data was taken, but it was never released. I wrote to the principal investigator of HiRISE, asked, can I get the data? I'm a scientist. You can do the press release afterwards. I would like to see it.
Right.
No response. And so it's already 3 weeks since that data was taken. That is the best image yet to come. And the advantage of it, not only it has 30 kilometers per pixel resolution, because it came very close to Mars, which is one of the anomalies. Why does it come so close? This object is a gift from interstellar space because it comes in the plane of the planets around the sun, and it also, the arrival time was fine-tuned for it to come to the right place at the right time, to be close to Mars, to be close to Venus, and then close to Jupiter. And not to Earth. It's behind the sun when the Earth, when it comes closest to the sun. Anyway, so it's best for observations by all the space assets, by all the orbiters we have around Mars, around Jupiter, on the way to Jupiter.
So has someone seen this image from...
Yeah, the people on the HiRISE team must have seen it.
And what do they say?
And just, I get a request for 4 to 8 interviews every day from television, from podcasts and so forth. So just before I came to you, a few minutes before that, I was asked, could it be that this is a signature that NASA holds some really sensational data? And I said, it's much more likely not to be related to extraterrestrial intelligence, but to terrestrial stupidity. Because this has to do with the government shutdown.
Right.
Makes no sense whatsoever for scientists, especially since the PI, the principal investigator, is from the University of Arizona. They should have shared it with scientists. They haven't done so.
And why? But why?
Because my guess is they're taking their time. The communication office of NASA, is not working because of the shutdown. But given that this subject is viral, this is the High-Rise webpage. Thank you, Jamie.
So it says any images of interstellar comet 3I Atlas,
3I Atlas,
are considered NASA-wide news because the federal government is in shutdown. Communications of NASA news has been suspended.
And
so that's what it is. Like they would have to release it through NASA.
Maybe they have written in the contract that they need approval from NASA, but for NASA not to approve it,
but NASA can't approve it because they're not working.
No, Sean Duffy, the interim administrator, can definitely say...
Can you get in there? Why don't you call Sean? Say, hey, what are you doing?
I should try that.
Yeah, why don't you do that?
Okay, because, this is important because this would be the best...
This is the best image.
Yeah, 30 kilometers per pixel. But moreover, more importantly, it's watching, the camera was looking at the glow around 3I Atlas sideways because it was moving towards the sun.
Got it.
And it looked at it sideways. So we can actually see what exactly it was doing on October 2nd. And the claim is during September, the month of September, what looked like an anti-tail, a jet towards the sun, changed into a tail during September. So we should see October 2nd. What does it look like? And by the way, it's not like it was not a beautiful tail the way you see around comets. Never, ever. And
that's because of the composition of it?
I don't know.
Right, because if it was covered with water, if it was just ice, you would see this enormous tail, correct?
And dust.
Yeah. Right.
So what the Webb telescope told us, from the data, it took a spectrum of the gas around it, found that it's 150 kilograms per second that this object is losing in the side facing the sun. Mm-hmm. And out of that, 87% is carbon dioxide, CO2. And 9% is CO, carbon monoxide, which is really dangerous to humans. And then 4% is water. 4% by mass is water. Very small fraction. When the object was discovered, the experts said, it's most likely made of water. That's what they said, made of water. And then several teams reported, we found water. I looked at their papers. One of them had very large error bars. The data was not of good quality. There was a lot of noise. And I said, that's not a clear detection. Another one was making some assumption about how much dust there is that blocks ultraviolet light. And based on that, they got a result that there is a lot of water. And then the Webb telescope actually measured the composition and found just 4% by mass water. So I was attacked when I said it's probably not real, that these teams are reporting things, but they are not real, even though they made press releases. But then Webb demonstrated that it's only 4% by mass. Okay, so that proved my point, even though I was not a member of those teams. But so it's 4% by mass water, and then the question is there any dust? If there was dust particles that are half a micrometer in size, roughly the size of the wavelength of visible light. These kinds of particles scatter sunlight very effectively. If that was the case, you would see them being pushed, those particles being pushed by radiation pressure from the sun to trail the object from behind it, away from the sun. Why? Because they're being slowed down. The object is approaching at some speed. They are slowed down, so that then you end up with a tail going away from the sun. And that's what you see in comets. There was no evidence for that during July and August. Now in September, it seemed to have reversed from being an anti-tail to a tail. I want to see the image
but still a tail that's very small compared to other comets that we've observed, right?
Yes.
Now, how many comets have we actually observed? Is it just that there's so many out there that a lot of them have very unusual characteristics, like 3I Atlas?
Well, just think about an animal that visits your backyard, okay? And Of course, your family members would say it's most likely a street cat because these are very common. Then you take an image of that animal and you see that, there is a tail, but it's coming from its forehead. And then you realize from the image that it's at least 1,000 times more massive than a cat, a street cat. And then you realize that it sheds nickel. And then you realize that it visits...
I understand that it's unusual, but my question is, how many of them have been observed to form this hypothesis that it's unusual?
We're talking about hundreds of objects.
Hundreds?
At least hundreds.
But how many of them have come from Interstellar? How many of them?
No, this is the second one.
Right.
There was Borisov.
Right.
Borisov was the one discovered in 2019, looked like a comet.
Right.
Very similar to
That's the point. The
solar
point is that
system.
there's so few that have come from that are interstellar
so
objects.
that's why I'm saying it could
we
be
don't
natural.
Have a lot to measure.
Right. So it could be natural.
Right.
And in fact, that may be the most likely association. But we need to figure out why it's so unusual. Okay, because
what is the shape of it?
We don't know because we don't have an image of the object itself. One thing
Do you
we
think
see.
they would be able to get it if they had this Mars footage? They would get an image of what that would indicate
depends how big the
shape?
object is. One way to get the object, structure is as it spins around. And 3i Atlas does have a rotation period of 16 hours. And as it spins around, if it's like a cigar shaped, let's say, then the area that reflects the sunlight changes over time. So you see variability. And we haven't seen that much. There is very little variability. So it's not the object is not very different than a sphere with slight variations as you see the rotation of the object.
So it's similarly shaped to something that you would expect to be from an intelligent life force.
I don't know that. I want to figure out what it is and get as much data as possible on it.
Right, but if you imagine a spaceship, you would imagine something that, has some sort of like geometric structure to it, right?
Well, Rendezvous with Rama, is a book that was written by Arthur C. Clarke. And in it, there is a cylindrical object that arrives into the inner solar system with dimensions of order tens of kilometers, not very far from what we are talking about here.
Mm-hmm.
Arthur C. Clarke was an amazing visionary science fiction writer, and 2001: A Space Odyssey is an amazing film that he made with Stanley Kubrick.
Yep.
In it, you see these monoliths. And by the way, there is a question of how to interpret them. The way I think about the monolith, and by the way, this is just a remark on art. It's not about the real universe, but I think of it as, sensors put in the baby room, in the room of a baby. And we, as a civilization, is like a baby. We're just a few million years old. And actually, in the film, it shows the progression of human history. And so as a baby, these aliens were putting monitors in the room to see what we are up to. And, that's something that makes sense. There is this dark forest hypothesis, one solution to Enrico. So Enrico Fermi, back in 1950, had lunch together with Edward Teller and other people associated with the Manhattan Project. And he was a very good physicist, both an experimentalist and a theorist. And Enrico Fermi was talking with them about extraterrestrials, and they all agreed that it's likely that they exist. Okay, as good physicists, that makes a lot of sense.
Right.
And then Enrico said, but where is everybody? In an Italian accent. Where is everybody? And if I were next to him, I would come to him and say, Enrico, I would put my hand around his shoulder. I would say, Enrico, this is a question that every lonely person asks. And what you tell a lonely person is, don't be so presumptuous. You are not that attractive. They will not come to you and have breakfast with you or lunch with you in Los Alamos when you want them to appear. You need to seek them. That's what you tell lonely people. You need to go to dating sites. You need to look through the window of your home and search for them. And he didn't build a telescope. An experimentalist asking this question should have built a telescope and searched for unidentified objects in the sky. That's the way to figure out the answer. Where is everybody? It's the most romantic question in science. But, and we have those blind dates. Maybe it's just with rocks, maybe not. And we should just be open-minded when we address those blind dates.
I think we could end it with that. It's a very perfect way of phrasing this whole thing. I'm fascinated by it all, and I'm really happy there's someone like you that's looking into this with such curiosity and that you're undeterred by all these haters.
Well, thank you. And I should just mention that, there are all kinds of technologies that I can imagine that we don't even have. And for example, if a civilization has an ability to create a negative mass that produces repulsive gravity, then you can propel a spacecraft without any fuel. In fact, I'm working on a paper now with a group of collaborators, applied physics, on this. And you could also potentially imagine time machines with negative masses. So there are lots of things we don't know. Let's be modest. The future,
unlimited possibilities, especially if we developed artificial general superintelligence, and it helps us, and it starts devising new methods of propulsion, new methods of, who knows, seeding the universe with other life.
Yeah, and just like in our private life, finding a partner can change your future to the better.
Finding an alien partner.
Yes.
All right. Thank you, Avi.
Thanks for having me.
Appreciate you being here. Thank you very much. Bye, everybody.